Guys, how we doing? Week 6, Gyro 5, U.S. Hard Kill Team. Sorry, I'm Ethan.
I'm Azim.
I'm Sarah.
Dawn.
I'm Lindsay.
And today I'd like to tell another story just to reinforce the problem that we're facing. So imagine yourself, you are in a platoon, you're patrolling the area, and you have heard of, or not heard, but you know that in recent events you've had friends and armed soldiers having explosives dropped on them from bombs above. And little do you know, there's a drone right here, and you have little time to act, but you know that if it gets close enough, regardless if you shoot it down or not, an explosive device strapped to the drone, if it gets near you and falls, you could have your entire life, taken away. So what do you need? You need some sort of solution so that you can detect it early enough and take it down before it gets too close.
So this week we really focused on understanding the M203 grenade launcher attachment and verifying that it was accessible to everybody in the military. And this one we actually declined. So we found out that in a squad in the military, only 2 or 3 people would be trained to use an M203. So some soldiers actually didn't have access to it. So we decided, though, as a team that still doesn't have any impact because currently they don't have something that's easily accessible in general. They usually have to carry something like a rocket launcher or something else to deploy current solutions. So we still felt that our current solution, or our MVP, can still provide benefits then. Our second one, so this one was looking into graphene, and we figured that might overcomplicate things for the actual solution that we had in mind. So we're looking into seeing if we can use a bird net instead. And this one, for actual experiment, we want to see if we can get a hold of a drone and see if we can launch a net at it somehow and see how that impacts the drone. And then our last hypothesis, this was something that we found in an interview, and it was a recommendation that instead of using a physical deployment of a net, we can look into something like an EMP, which is electromagnetic pulses, to see if we can take down the drone in that way. And then for our customer discovery methods for next week, the big interview goals that we have in the upcoming week is continue our discussion of our MVP. We need to understand how feasible it is with all these subsystems connecting with each other. And then we also want to see if we can condense any functions together. And then the safety. So this one is a huge thing that got brought up. So since we have propellant, and Lindsay's going to talk about that a little bit in our MVP that we changed a little bit, there's going to be propellant in the second stage of the bullet, and we're a little concerned that if it's getting deployed from an M203, the actual firing pin can cause the propellant to blow up. And so we need to understand and make sure that that's something that's not going to happen. And then the other thing that we want to look into is exploring the EMP options instead of the physical deployment of the net. And then we also need to look at the sensors. We actually talked to our sponsor, and he said that the cost of the sensor doesn't matter that much, and that the consistency was more important. So I think that was very big for us. And he said that he was looking for something that had something greater than 80% takedown rate. Yeah.
So this week we did a little revision on our mission model canvas, specifically with our mission achievement section. So as Azim mentioned, we're looking at the accuracy of the sensor, and what we found is that sensors have even the best sensors out there, have between 70 and 90% accuracy, which isn't a lot. So as we're developing what our goals are, we're trying to keep that in mind. We want reliable accuracy in detecting and taking down enemy drones, and we're beginning to consider what is success going to look like given the current state of technologies that we have accessible to us. We want to eliminate drone casualties to a small margin, around 90%, and also add activity for accessibility in every squad. So as Azim mentioned, when we learned that the M203 is accessible only to a few members in each squad, we realized that still had enough accessibility because there only needs to be a representative of the technology in every squad in order to protect the squad. So those are some measurable goals that we can achieve.
Did you have to go back?
The customer archetype hasn't changed, but we're looking at an infantry soldier who has been trained and will need to receive some further training in the safe use of this product.
All right, so not much has changed from our VPT since the last time we had this talk. Although, like Azim said, we found out that not everybody in the infantry knows how to use the M203, so we did highlight that as a pain. But outside that, not much has changed.
Okay. For our customer workflow, it's pretty much still the same as an enlisted soldier. You detect the drone, you analyze the environment, and then you determine if it's an emergency. You make the decision of a hard kill, soft kill, or no action. We're still sticking to our MVP of the Jitus bullet. We have a different picture here since the last bullet. So this is a bullet that would accurately go into the attachment of an M203. We don't know for sure if that would be directly our bullet, but it's something similar to what we would want. Still a two-part system. The second part of the bullet would actually protect the netting from burning from the propellant that we're investigating. It would still have a tracking system, so I looked into a lot of different types of tracking. There's one that's called Tracking Pro, I think, and basically it tracks the target before it's deployed, and it kind of locks onto the target, and the bullet will have a sensor inside of it that also goes along with the Tracking Pro device, and it would deploy when it locks onto that target, and then the sensor would, because of the computer that has already calculated the distance of the drone, then it would deploy at the amount that it gets close enough to the drone. The netting system would deploy. And so some of the pains and gains would be accessibility, easy to train the tracker, of course, would be a good gain. Eliminate shooter error with the tracker, lightweight system, and then this would be a fast reload for all the soldiers. Some of the pains are the safety of the soldier, referring back to the propellant, and then the consistency to make sure that the tracker and the netting system works, 9 out of the 10 times, or hopefully 10 out of the 10 times. Integrating the sensor inside the bullet, again, the tracker. Weather shouldn't be too much of a problem if we find out a good tracker and sensor, because those things will have like a 0 point and be able to contribute to the weather, and then distribution of how to get the product to our soldiers.
All right, time's up. Let's anybody have feedback?
Yeah.
So you guys have been interviewing various beneficiaries, and you said with I think your VPC that nothing's really changed. And it seems like, are you finding yourself still interviewing beneficiaries that have the same relationship to the problem, or are you expanding your circle around that? And if so, are there any deductions you can make about where you are in this process?
So I think with the specific VPC that we have on this slide, that's for the military, and generally speaking, from the people that we've interviewed with the military, they share a lot of the same pain points and gains with what we have with the technology currently, or current solution. There are other MVPs, like for example our sponsor, that we could highlight next week and see how they have their perspective into it as well, if that's something that would be of interest.
But we do actually have a very diverse group of people that we're interviewing. It's actually not primarily military, which is who's represented on the VPC. So.
The reason I ask is an interesting question. If I were in your group or in any of these groups, I might say to myself, when do I know that enough information is enough that allows me to go to step B? When can I take the next leap?
I definitely think we've gotten a lot of information, and we're kind of now, I think, shifting towards more information on our VPC.
And I would add, we're super specific with your information, right? You're doing a great job initially at kind of broadening out and talking to a lot of different people. And now it's time to start narrowing down and hone in on your solution and what is, who's going to specifically be using that, and getting more specific with your questions and the people you're speaking with.
I'm curious about, because I'm privy to the chatter on Slack, what have you made of the fact that there is a product that exists like this?
It's not similar at all to ours. So the Skywall 100 is only for civil and domestic environments. It only shoots at like 100 meters. It's a huge bazooka gun that you have to throw over your shoulder. The bullet is big. I think the gun and the bullet itself is 22 pounds.
And it's not a smart bullet.
Yeah, it's not a smart bullet. No way would a soldier say, okay, I'll carry that around. So,
Good.
yeah.
Good.
The accuracy number, where did you get that number?
I was saying, hopefully, the accuracy number would be.
I can provide, actually, there, and people I've interviewed have told me that for radio frequency, that tends to be the most accurate scanner, and that's between 70 and 90%, according to my interviewees.
And you obtained that information from a non-military person, or?
From a retired military person.
One way to move forward with that is to think about what technology is needed to improve that and where are differences in technology being made. So perhaps the technology isn't there, but if you can figure out where the deficit is and how that movement is going, you may be able to project where the best place to put your efforts based on how technology is moving. I know that's a kind of a complex thing, but just to give an example, like solar powered stuff, the battery is a limitation right now, right? But we know that if we develop around the battery, as the battery moves, we'll be able to develop better solar powered stuff.
Right.
So you kind of have to understand where that deficit is and take your movement based on that.
That's great.
Also think the combinations of technology, so if you have a 90% reliable technology combined with a 90% reliable technology that work in different or orthogonal ways to each other, you know, you have redundancy, if you will, in extra ways around that.
And I'd like to ask a follow-up question on that. When you say 90% or 70%, what do you mean? 70% of the times it is accurate, or?
Yeah, that it would detect the drone 70% of the time accurately.
10 times.
Yeah, so it's not that impressive.
So, yeah, 7 and 10 times, yeah.
Thank you. 1, 2, 3.